Hello everyone, this is Unofficial Sando. Today let's talk about Leetcode 1609, even or tree. If you like these videos, you could support me by subscribing my channel or click the likes of the video. You can find the complete code and of my video in a list in the description below. Let's look at the problem description first. So first of all, even or tree is a binary tree, and if the root is marked as level 0 and its children are at level index 1. For every even index level, all nodes have odd integers in strictly increasing order. For every odd index tree, then each level have even integer value in strictly decreasing order. If we look at examples, it may be better to understand. So the root is always level 0 and then level 1. For level index as even, is all the node value has been odd value. So the root is 1, so it's a mid requirement. Then for level 1, all the nodes number has to be even, and it has to be also strictly decrease from left to right. Then 10 for meet the requirements as well. For the level 2s, all the nodes are odd and strictly increasing. And same for the level 3. So we call this tree as even or tree. Then let's look at example 2. Root node 5 is okay, and for 2 strictly decreasing. The problem is happening is for level 2, because we have two nodes have same value, so it's not strictly increasing. So we call this tree is not a even or tree. When you go through the examples, you can really understand the way we have solved this problem is we want to do a level order traversal. Actually, this is the purpose for these videos. It's just introduce how to do tree levels order traversal using breadth search. Let's use the second examples to show how is the basic BFA's workings for tree level order traversal. As always, we'll put the root node in a queue, right? So then we start to do the BFA search. We pop out the front of the queue. So the current node will be 5, since it's only node in the queue. We have a dummy node to dummy for the initial value, because 5 is the initial value of this level. We put 0 because for this level we want to strictly increasing. After that, we push its child, if it has any child, into the queue. So here, for 5, we pushed 4, 2 in the queue, and we will check as well. The 5 is odd and is strictly increasing, so the check is okay. And then we pop out the first values from the queue, so which is 4. Because 4 is the first element we will traversal in this level, so we also have a dummy node put as marks, because for this level we want to strictly decreasing. Also, we will push its child 3, 3 into the queue after 2. The check is also okay because 4 is even number and it's strictly decreasing. Then next is 2. Is previous node is 4, then we check is strictly decreasing. We also push its child into the queue, then switch 7, and then 3, 3, 7 checks also okay. For the second level, 3, its previous node as a dummy node because it's first value, strictly increasing. Because it doesn't have any child, so the queue right now is 3, 7. The check is also okay. The problem is for this node, Its previous node is 3. However, the current node is 3 is not strictly increasing. We can stop here, and we just, because the check is false. So after you looking for the kind of trajectory, we do the traversal. You can find this kind of pattern, right? So for BFA search, we start from 5 and next 4, 2, then 3, 3, 7. So exactly we are traversal the tree level by level and from the left to the right. So next, let's look at the implementation. The code covered by this green rectangular is the template I made for the BFS. So you can try to use this for others BFS problem as well. For the template, you first initialize Q and push the root. We will have 2 while loop. So first while loop is check whether the Q is empty. We have a variable num to record the current Q size. Then the next while loop is to iterate till the num is going to 0. There's other application which use another Q to restore the next level node. So by utilize num, so we don't need to have another queue to record the next node. We can use only one queue to store all the nodes, and this num just tell us how many nodes left for this level to traversal. So it's good to save some memory space. Then in this one loops, we get a from number and we pop out and we decrement the num. Then for next if, just check whether the current node is meet the requirements for the even or tree. Then we have a is even Boolean flag here to tell whether it's a even layer or all layers, which is will run in different check. We also save the previous value to check the increasing or decreasing requirement, and we push the current node childs into the queue. After we finish this while loop, which means we are done one level traversal, then we will flip the is even flag as well. So eventually, if we find some node doesn't meet requirements, we return false. Otherwise, we return true at the end. The computation of complexity for breadth search is big of n because we will, worst case, we will have to visit all the nodes of a tree. The space we can also think is big of n as the last levels nodes too many compared with the previous node. Okay, that's all. And if you have any questions, feel free to drop your comments. Otherwise, I'll see you next video.